Hello everyone. Today let's solve the problem number 150. Evaluate reverse Polish notation. Right. So you can just go through the question and also you can just try to understand the question with the help of example as well. They have clearly mentioned the examples and they have explained the examples as well. So I'll just try to summarize the problem for you so that it will be easier to understand. Right. So what the question states here, we are given a list of tokens representing a mathematical expression in reverse Polish notation. You can clearly see here, sorry, not this one, this one. We have been given a list of tokens, this one, list of tokens representing a mathematical expression. You can clearly see here, representing a mathematical expression in reverse Polish notation, right? RPN. What is our main task then? Our main task is to evaluate the expression and return the result as an integer. We have to evaluate the expression and return the result as an integer. So what is the rules here for the reverse Polish notation? Operands, when I say operands, it's the numbers, right? Numbers come first, followed by the operator. Numbers has to be always first, followed by the operator. You can clearly see here. Numbers comes first, followed by the operators. Operators like this one, plus, minus, star, this one, multiplication and the division symbol. Apply to the last two numbers on the stack. They have clearly mentioned they apply to the last two numbers on the stack, and division truncates towards the 0. And this we have to keep in mind. What are the things here? What are the rules here? Numbers come first, followed by the operator. Operators like addition, subtraction, multiplication and division apply to the last two numbers on the stack. The final one is division truncates towards the 0, nothing but the integer division. This is the these are the rules, right? So let's first, you can clearly see the example here, 2, 1 plus and this one. They have done 2 plus 1, nothing but this one, 3 into 3, 9. Explanation they have clearly given here. Same goes with the example 2 and example 3. Let me explain one example entirely and then let's go with the approach and this one, edge cases, then finally write the code and discuss the complexities, right? So let me consider this example, right? This example, let's go step by step. First, initially what we have done, we have considered this example. So let's start with the empty stack basically. So we'll be going with the stack approach. We'll go with this one, empty stack. The second step is we have to push the numbers until an operator appears, right? So until an operator appears, first we will be pushing 10. Then we will push 6, nothing but in the next step it will be 10, 6. Next we'll be pushing 9. So in the third step we'll be pushing 9, it will be 10, 6, 9, and finally we'll be pushing 3 here. So it will be 10, 6, 9. This will be the first step, right? So we have pushed the numbers until the operator exists. So here next it will be plus, right? Now what we have to do is we have the operator plus. So we will add the top two operands. We have the top two operands in the stack will be the last two numbers, right? This one, we will be adding this one, nothing but 9 plus 3. This one, plus we'll be making use of, we'll be adding 9 plus 3 here. It will be now 10, 6, 12, right? So now what we have done, we have popped 9 and 3 and then we are pushing the 12 to the stack. Now the stack becomes in the second step 10, 6, 12. I hope this is clear, right? In the fourth step, we'll be pushing minus 11. This one, we have already considered these 5 things. Now let's go with the minus 11. Here, this will be 10, 6, 12 and minus 11, right? So next we have the operator, this one, multiplication operator, right? Now what we will do, we will multiply the top two numbers at the stack, nothing but these two. While I say top, this is last two numbers, right? 12 into minus 11 is nothing but minus 132. So now we will have 10, 6, 12 and minus 132 in the stack, right? So I hope this is clear till here. Let's move on with the fifth step. So what we will do now, we have the this one, division operator, I think. So yeah, let's go with this one, right? So what we will do here, we will divide the top two numbers. While I say divide the top two numbers, now we have 12 and minus 132 at the top of the stack, right? The top two elements. 12 by minus 132, I think. Just give me a second here. We have something wrong I have done here. So yeah, here we have to multiply 12 and minus 11. It has to be minus 132. Why I have given here 12? Sorry, the last two numbers at the stack will be now 6 and minus 132, right? It has to be, in the next step we are considering the division symbol. So we have to go with 10, 6 and minus 132 we have. That is nothing but we are dividing the last two, this one, 6 by minus 132. So this will be basically this will be equal to 0, right? This will be equal to 0. So now the solution will be 10 comma 0 at this point of time. It will be 10 comma 0. Next we have this one, multiplication symbol. So I'll just come here. We have to multiply the last two this one elements in the stack. So this 10 into 0 is anything multiplied by 0 is 0 here in this step. So this will be 0, right? Next step is we have the number 17 here. You can clearly see we have to push the number 17 and then we will go with the addition symbol. So here, let me come here. Let's push this one 17 and then what we will do, so we had already 0, right? Sorry, here. Just give me a second here. We had already 0 in the stack. So we are pushing 17. Now it will be 0 comma 17 here, right? So now after 0 comma 17, now we have this one, plus symbol, right? Now let me come here. We have to add the this one, the last two elements in the stack, nothing but 0 plus 17 here, nothing but 17, right? Now we have again, now we have 17 in the stack. 0 plus 17 is nothing but 17. So now we have 17 in the stack. Next element here is we have 5. We have to push the 5 to the stack, right? Now it will be 17 comma 5. So next step is, let me come here. What we have here, plus, right? So it will be 5, right? We have the addition operation now. So we are adding the last two elements in the stack, nothing but 17 plus 5. It will be 22 finally. So the answer will be 22 for this, right? So I hope this is completely clear. So let me delete this one. Just give me a second here. So yeah, now what we'll do, let's discuss the approach. I hope the example that I explained is completely clear, right? Now let's do one thing. Let's go with the approach and then let's discuss the edge cases and write the code and discuss the complexity. Here let's discuss the approach step by step. Just give me a second here. So the first step is we will make use of the stack to process the expression. So as I've said, we'll be making use of the stack to process expression. Just keep in mind, this will be easy while we write the code. So just try to understand the approach. So we'll be making use of the stack to process the expression. Next step is we will iterate over the tokens one by one. Nothing but second step is iteration. We will be iterating over the tokens one by one, right? So the first step that we need to consider within the iteration is if token is number. If token is number, Then what we will do? We will push it onto the stack. Push it onto stack. This is fine. And what if token is this one, the operator? So we have number and operator, right? So we saw that one in the example. What if token is operator? We saw in the example, we will pop two elements. If you remember the example that I have showed, we will pop two elements, then apply operation. After applying operation, we will apply the operation means whatever the symbol that we have given. So whether it may be addition, subtraction, multiplication, division, plus, minus, slash, or this one, multiplication symbol. So, and then after applying the operation, we will push the result back here. Push result back. That's what we will do if the token is operator. I hope this is clear. If the token is number, we will push it onto the stack. If the token is operator, we are popping the two elements, apply the operation, and push the result back. This is the second step. This involves in the iteration basically. So first we are going with the stack approach. We are processing the to process the expression. Next, we are going with the iteration, nothing but each token one by one. If the token is number, we'll push it onto the stack. If the token is operator, then we'll pop two elements, apply operation, and push the result back. So next, let's move on with the third step. So here, at the end, stack contains the final result, right? So at the end, stack contains the final result. So this is the approach that we will be going with. While we write the code, it will be completely clear. So this is the approach that we'll be going with. Next, let's discuss all the edge cases one by one and then write the code, and I'll explain the complexity. So let's go with the edge cases one by one, right? So first edge case, let's go with the simple addition here. The input, let me consider here 2, 3, as well as here, let me consider addition symbol. This is fine. So output will be here 5. So here we know that it will be 2 plus 3, right? So we are adding the last two elements in the stack. This is nothing but 2 plus 3. Here it will be 5. So here, this is fine. This is for simple addition. This is fine. This is the first step and first edge case. Next, go with the second edge case, nothing but division with truncation, right? So during the explanation, I said that division truncates towards the 0, nothing but the integer division, right? So let's go with this one, 10. Let me consider 10. Let me consider 3. Let me consider the division here, division symbol. So the output will be here. This will be 10 by 3, and this will be truncated towards the 0, right? So the output will be 3 here. So output will be 3 here, right? This is for the division with truncation. So let me give here division with truncation, right? I hope the second edge case is completely clear. So let's move on with the third edge case. Third edge case will be, this is for the complex nested operation. Whatever example that I have explained, I'll consider the same example here. Here, I'll not be explaining the step by step here. So we have already seen this one with the this one while I was explaining the example one, right? The same thing, the same example I have considered here. So the output will be 22 for this. We saw this one, right? Already. The output will be 22 for this one. This one will be for complex nested operations, right? So how we got 22 here? We already saw this one, right? So this is fine. So what are the edge cases that we went with here? The simple addition, division with the truncation, and finally the complex nested operations, right? These are the three edge cases that we have to keep in mind. Let's next let's start writing the code. I'll explain the code while I write the code itself. And finally, let's discuss the complexities, right? So here what I'll do, as we had discussed in the approach, initially, let's initialize a stack to process the tokens. So let me consider here. Yes, this is fine. Let's loop through each token in the array. Second step, right? So I'll just come here. Just consider x of tokens. This is fine. Next step is we have to check if the token is an operator or operand, right? So for that, I'll just give you x. Well, let's compare this one with the operators. So this one, either it can be plus, or let me copy this one. There are 4 operators, right? We need to check for. So this one again, let me copy paste this one. This one. So let me change this one to minus here. This one will be multiplication. This one will be division. This is fine. Within this one, we are popping the top 2 elements from the stack after this operation. So we have to consider first operand and the second operand, right? Let's initially consider the second operand. As this is stack, the last 2 elements is we have to consider the second operand first and the first operand next, right? So I'll just give here, this will be the second operand. I'll just give here s dot pop, and let me consider the first operand. This will be s dot pop as well. The variables I have considered b and a. Nothing but second operand and the first operand. So next, after completing this operation, so we have to perform the operation and push the result onto the stack. If you remember the this one example or the approach, right? For that, for the push operation, I'll just take the push here. This is simple. Just give me a second here. We have to perform the operation, right? Addition, subtraction, multiplication, and division. So I'll just consider here. If it is plus, let me consider the ternary operator here. We are performing addition here, right? So next, let me copy the same thing over here. I'll just make the necessary changes here. If this will be for subtraction, this will be for multiplication, and this will be finally for division. Here also I'll do the same thing. A minus b multiplication, finally, division. This is fine. So this will be actually the division truncates towards the 0, right? So let me do one thing. For this, what I'll do, we have the truncate operation, right? mat.trunc. I'll just make use of this one. Let me give a by b. So this is fine, I think. So here this is fine. Else what we will do, we have just performed the operation and we are pushing the result onto the stack here in the previous step. So else what we will do, if the token is operator, then we are doing this operation, right? So what if the token is number? If the token is just a number, we will push it onto the stack. We have already seen this one in the approach. So I'll just come here. I'll give push of plus x I have considered right here. Yeah, x of tokens. This one. Yeah, this is fine. We are just pushing it onto the stack. If the token is number, we are pushing it onto the stack. Nothing but we are converting to the number and there we are pushing it. This is fine, I think. Final step is we have to return the final result from the stack. So final result is nothing but here. Let me return SO0. The first element, nothing but the first index here. The element present in the first index, S of 0, right? So I'll just format this one once. Let me hit the run button. I hope unexpected token equals here. 4 times I have given. Sorry. Yeah. We delete this one once. Let me hit the run button again. So again, everywhere I have given 4 times. Sorry. So now let me hit the a run button. I hope this works. Yeah, now we can clearly see the sample test cases are getting passed, right? So let me hit the submit now. So you can clearly see here all the test cases are getting passed, right? So the code is getting accepted. So let's quickly discuss the time complexity and the space complexity here. So what will be the the approach that we went with here is stack. We know, right? Stack based evaluation. So what will be the time complexity here? It will be big O of n. The overall time complexity here would be big O of n. Why the time complexity here is big O of n? Because each token is processed once. We are making use of the for loop and we are processing the each token once. So the overall time complexity would be big O of n. And what would be the space complexity here? The space complexity would be here big O of n as well. Why the space complexity here is big O of n? Because space used by the we are making use of the space that is used by the stack of operands. You can clearly see here, right? So that is the reason overall space complexity would be big O of n as well. I hope the solution is completely clear. So for now, this is it. Thanks for watching, guys.